Alright, this is part 2 of section 2.4. As I was saying in the last problem, I'm going to distribute that negative 4i to the 2 and to this 3i. Okay, so let me get rid of all my markings here. So I'm going to have first 3 times 2, so that gave me 6, plus 3 times that 3i, so that will be 9i, and then going to have negative 4 times this 2 times this 3i. So negative 4 times 2 will be negative 8i. And then negative 4i times 3i, that will be a negative 4 times 3 is 12. I times I is I squared. Okay, now I'm going to combine. Actually, I'm going to change that I squared to negative 1 first. Okay, so that will be 6 plus 9i minus 8i plus 12. Now I'm going to combine the 6 with the 12. That will give us 18. And then the 9i minus the 8i. So that will be plus I. And that will be our answer. Now let's look at this one. Negative 4 plus 7i squared. So that's the same thing as saying negative 4 plus 7i times itself twice. Negative 4 plus 7i. So I'm going to take this 4 here and distribute to this negative 4 and this 7i. So negative 4 times negative 4 will give me positive 16. Negative 4 times that 7i will give me negative 28i. Okay, then I'm going to come over and distribute the 7i to this negative 4 and to this 7i. So 7i times negative 4 will be negative 28i. 7 times 7 is 49. I times I is I squared. I'm going to go ahead and change that I squared to negative 1. So we have 16 minus 28i minus 28i minus 49. Then I'm going to combine the 16 with this negative 49. So that's going to give me negative 33. And then negative 28i minus negative 28i, that's going to be negative 56i. And that's going to be our final answer. Now let's look at this. Square root of negative 27 times the square root of negative 5. So the first thing I'm going to do is rewrite that. Okay, the first thing I'm going to do is take the i's out, so the negatives will go away. So that will give me I square root of 27 times I square root of 5. Okay, then we can combine this I squared times the 27 times square root of 5. So we know that this is going to be negative 1 times the square root of 27 times the square root of 5. Now let me deal with the square root of 27. So negative 27 is the same thing as 9 times 3, then times that square root of 5. So square root of 9 times the square root of 3 times the square root of 5. So negative 3, then times the square root of 3 times 5, this times this, would be 15. So then this right here will be our final answer. Now dividing complex numbers. Okay, so dividing, it says it's more complex, or dividing two complex numbers is more complicated than adding, subtracting, and multiplying because we cannot divide by an imaginary number. Okay, read that again. We cannot divide by imaginary number. We need to find a term by which we can multiply the numerator and the denominator that will eliminate the portion of the denominator. eliminate the imaginary portion of the denominator so that we end up with a real number in the denominator. Okay, so the number or the term that we need to multiply to the numerator and the denominator, that is called the complex conjugate, which is found by changing the sign of the imaginary part of the complex number. Okay, so the complex conjugate of a complex number. So our complex number is a plus bi. The conjugate of a plus bi is a minus bi. Notice how we went from a positive to the negative. We just changed the sign. Okay, so it is found by changing the sign of the imaginary part of the complex number. And the real part of the number is left unchanged. Notice how the positive a is still positive a over here, but positive b is not positive b over here. It is now negative b, and that's b is the imaginary part, a is the real part. So when a complex number is multiplied by a complex conjugate, the result is a real number, like it is right here. Okay, I have a complex number, and then I have the conjugate of that complex number. And then I get down to a number squared plus a number squared, which will give me just another number. You don't have to go through, you don't have to know all this stuff right here. Just know that when you have a complex number and it's multiplied by the complex conjugate, you're going to get a real number. And also when a complex number is added to the complex conjugate, like it is here, you will also get a real number. Notice it's 2 times a, and a is a real number. 2 times a real number will again be a real number. So let's look at it in like this. Find the conjugate of negative 3 plus 4i. Well, leave a alone. Change the sign in front of the negative, or sorry, in front of the imaginary number. Done. Find the product of negative 6 minus 5i and its conjugate. Negative 6 minus 5i times its conjugate, negative 6 plus 5i. Okay, 6 times 6 is positive 36. Negative 6 times 5 is negative 30i. Okay, and then negative 5i times negative 6, that is positive 30i. Negative 5i times positive 5i is negative 25i squared. I'm going to go ahead and get rid of my 30i. I have a negative and positive. So 36 minus 25 times negative 1. So 36 plus 25. That's going to give us 61. I'm going to come up here. Okay, so notice I multiplied a complex number times its conjugate, and I'm getting out a real number, 61. Okay, divide and simplify. So 6 plus 3i divided by 5 plus 2i. 6 plus 3i divided by 5 plus 2i. Okay, notice I have division here, and back over here it says we need to find a term to multiply the numerator and the denominator, so we'll eliminate the imaginary portion of the denominator. And we said that was the complex conjugate of the denominator. Okay, so go back over here. So multiply the top and bottom by the conjugate of the bottom. So 5 minus 2i, 5 minus 2i. Because remember, a complex number times its conjugate will give us a real number. Okay, so I have 6 plus 3i times 5 minus 2i over 5 plus 2i times 5 minus 2i. Okay, so let's see, I'm going to go up here. 6 times 5, I'm just distributing, is 30. 6 minus, or 6 times negative 2i is negative 12i. 3i times 5 plus 15i 3i times negative 2i is negative 6i squared. All over 5 times 5 is 25. 5 times negative 2i is negative 10i. 2i times 5, positive 10i. 2i times negative 2i, negative 4i squared. I'm going to get rid of these 10s. I'm going to combine the negative 12 and the 15. So I've got 30 and then plus 3i. And then I'm going to change that I squared to a negative 1. So that'll give me positive 6 over 25. Okay, change that I squared to a negative 1 plus 4. Okay, so I have 36 plus 3i over 29, and then break them up. 36 over 29 plus 3i over 29. And this will be our final answer. Okay, we'll do the same thing here. We've got 1 minus 3i over 1 plus 2i. Multiply the top and the bottom by the conjugate of the bottom. So 1 minus 3i times 1 minus 2i, 1 plus 2i times 1 minus 2i. Come over here. 1 times 1 is 1. 1 times negative 2i, negative 2i. And negative 3i times 1, negative 3i. Negative 3i times negative 2i, positive 6i squared, divided by 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is 2i. Positive 2i times negative 2i is negative 4i squared. And I'm just distributing. 2's can go away. I have 1 minus 5i. 5i. This will change, this right here will change 6 to negative, so negative 6. 1, this right here will change negative 4 to a positive. Okay, so I have a negative 6 minus 1, so I have a negative 5 minus 5i over 5. So negative 5 over 5 minus 5i over 5. So this is negative 1 minus I. And that will be our final answer for that one. Okay, now let's look at negative 2 divided by 1 plus I. So same thing, multiply the top and bottom by the conjugate of the bottom. So that will be basically negative 2 times this right here. And we have 1 plus I times 1 minus I. Come up here, so that's a negative 2 plus 2I over 1 times 1 is 1. 1 times negative I is negative I. I times 1 is positive I. I times negative I is negative I squared. I's go away. Negative 2 plus 2I. 1. Okay, this right here is going to be a negative 1. I have a negative in front of that. So negative negative 1 is positive 1. And I can write that out. Minus negative 1. Negative 2 plus 2i, 1 plus 1. So that will give me negative 2 plus 2i over 2, which, let me come back over here. I'm running out of room. So we've got negative 2 over 2 plus 2i over 2, so negative 1 plus I, and that's our final answer.